Hello everyone and welcome to CS 1400 Fundamentals of Programming. We will start this course by talking about software and Java programming. Let's discuss the expected outcome after completing this module or this chapter. Upon the completion of this module, you should be able to define software and different software kinds. You should be able to know what a program is and what a compiled program means. We will also get familiar with the different components needed to program in Java. We want to also get familiar with the term IDE, which stands for Integrated Development Environment. So the IDE is a program that is going to help us write code in Java. But first we will learn how to write code without an IDE, and then we will dive into an IDE because it will need some learning on how to utilize it. Finally, we will be able to write our first Java program. Now let's talk about software. We hear the word software everywhere, but what is software? First of all, we should all know that a computer is not useful unless we instruct the computer to do something. So if we have a computer without any instructions or any software on it and we turn it on, what we are going to get is just a blank screen, nothing else. The computer is waiting for some instructions that will tell it what to do. And here where the program comes in. A program is the instructions that will tell the computer what to do. Now the program can be stored on electronic chips, which can be part of the computer, and we mean the hard drive by that, or on some storage devices like CDs, DVDs, USB drives, and so on. The term software can refer to a single program or even a set of programs. We have two main kinds of software, the first one being application software. These are programs that we will use and we will need to do some tasks such as word processing, spreadsheets, games, and so on. Good examples would be Microsoft Word, MS Excel, and any game that you can install on your computer, some video applications that will play back your video. So these are all application softwares. They are also known as applications. The other kind of software is what we call the system software. Now these special programs will help the computer do its job. We are talking about the operating system here or some network softwares. The operating systems will include Windows, Mac OS, Unix, and so on. The computer is not going to be able to perform some tasks without having an operating system. You cannot operate the computer without an operating system. Now, software is not restricted to computers. Many other devices have software, such as game consoles. Even microwave ovens have some software, and we call this embedded software. If we have the microwave oven with just the buttons without any software to tell it what to do when we press a certain button, then the microwave oven is going to be useless. A software is going to be built by writing a set of instructions for the computer to obey those instructions. This is called programming or coding. So programming or coding is the process of writing the set of instructions that will tell the computer what to do. Now there are many languages and there are some specific languages for some specific purposes. We have some languages such as C++, Visual Basic, Python, and many others. Now the language we are going to be using for this course is called Java. Now this takes us to what we call compiling programs. Now in Java, instructions are written in human readable language. We call this the program code or the source code. Now, as we may know, the computer only understands binary instructions. Now, binary instructions are either zeros or ones. Now, how can we transform this human readable code into zeros and ones? So the zeros and ones, which is the binary instructions, are also called machine code. We will have something in the middle, and that something in the middle is called compiler. The compiler is going to translate the source code into machine code. So it's going to take the program code or source code, which is human readable, and it's going to translate this into a machine readable version. This process is called compiling. So when you say I'm compiling my code, that means you are transferring or transforming your code from human readable into machine code. Now, just like human language, a programming language will have a set of rules. This set of rules is called syntax. Why is that important to know? Because a code with syntax errors will not compile. So if you have some errors in your rules or in your syntax in this case, you will not be able to translate this into machine language, so you will not be able to run your code. Once the code is compiled, it can be run as many times as needed, so you wouldn't have to recompile it every time. You can just run it right away. Now, when we try to talk about software that we just mentioned, is it a source code or is it a compiled code? If we think about it, the code, when it's compiled, can be run as many times as needed. Do we have to compile the applications that we use? The answer is no. Can we run them as many times as we need? The answer is yes. That tells us that when we get a software, we are getting the compiled version of that code and we are not getting the source code. Now let's talk about programming in Java. So before Java, programs are usually written for a specific machine. When the programmer writes a program, compiles it, it compiles for a specific machine, and if you try to run it on another machine, you will not be able to do that. Now, this is a problem because the compiled program is suitable only for that machine. So if I design a program for, like, let's say a Windows machine, and I want to use it on another machine, let's say Unix or Linux or Mac, then I will have to rewrite my code, which is not a good thing. How does Java solve this problem? Java is called platform independent. So the Java program can be the same for different devices. We can have the same Java code, and when we compile that Java code, we can run it on any device, or we can actually compile it and run it on any or multiple devices, let's say. That device, in order for it to be able to compile and run the Java code, and that's why I said not any multiple devices, so we have to have this condition on the device to be able to compile and run the code. We will need something called JVM, which is what we call the Java Virtual Machine. Now this is going to serve as a virtual machine that will run the code on each one of those different machines, and so we will not have to write a specific code for each machine, but we will have just to write a code that is going to work on our JVM, and this is going to provide us with the same code that runs on multiple machines. Now, as we said, this will run the Java program on any computer, and in some computers, JVM comes packaged with what we call Java libraries and packages. These are pre-compiled modules that can be integrated with a Java program, as we will see later on in the course. Now, those libraries together with the JVM are called JRE. By JRE, we mean the Java Runtime Environment. The Java Runtime Environment is what's going to run your code. We also have one component that's called JDK, and this stands for Java Development Kit. Now, the Java Development Kit includes the JRE and some development tools like your compiler. Your compiler is going to be in the Java Development Kit because remember, you are writing your code, you're developing the code, so it's going to be in the Development Kit. Now, the IDE is the Integrated Development Environment. As we said, this is a tool that is going to help in writing and compiling the code, but you don't have to use the IDE. Now you can write your source code using an IDE or without an IDE. As we will see, we will be able to write our code with just a text editor. So if you have any text editor, you will be able to write your code in there. So we will write our code here, which is what we call the source code. Now the source code is going to go to the compiler. The compiler, as we said, is in the JDK. So we will jump into the Java Development Kit. Now this is going to give us something first. It's not the machine language right away. We will have the same file name. So if our file is called source.java, we'll have something that's called source.class. And this is, as we'll see later on, is called the Java bytecode. Now this class file is what's going to get run on JVM. Now the JVM will be either a JVM for Windows, JVM for Mac, or JVM for Unix. You don't have to worry about that. The only thing you have to worry about is writing your code or source code right here, and you don't have to worry about any of this. It's going to work on any other machine. Now this class file is going to run on either of those JVMs, and each JVM is linked to a specific operating system. And this is how Java will work and make your code work on any of those machines. Now the question that comes here is, why Java? Why specifically Java? Now Java is relatively easy to learn. It was designed to be easy to use, so it's easy to write, easy to compile, easy to debug, and easy to learn. Now writing the code, we know, is just writing the instructions. Compiling, we just define compiling as translating the code or source code into machine language. What is debugging? Debugging is when you try to get the errors out of your code. So sometimes you have a code with errors and it's not compiling. Debugging is getting rid of those errors to make your code compile. Now sometimes you will have errors which are called logical errors, as we'll see later on. Your code is going to be compiling, but it's going to have issues running, and that's also some sort of debugging. The other thing is Java is an object-oriented language, so it allows the user to create modules and reuse the code. So you can create a module for something, some object, as we'll see later on towards the end of the course and towards the beginning of the other course, which is 1410. You can create some kind of object in Java. So you can create, let's say this is a person, and you can create the code that defines the person, defines all of the attributes, all of the characteristics of the person, and compile this, and you will have this ready to use whenever you need it. So if you have some other code and you want to use this code in person, you don't have to rewrite it. You can just use that. And this is one of the advantages of Java. Now, another advantage of Java is that it is platform independent. As we said, it allows using the code on different machines without the need to rewrite the code.